This is a CCEA Mathematics Pass paper, and we're looking at M7 paper 1. It's a non-calculator paper, and this is from January 2020. So let's take a wee look at question 1. A sequence is formed using the rule find the next term by adding the previous two terms. Use this rule to complete the sequence below. So the first term is x, the next term is 4. If we add those two together, we get x plus 4. The next term then will be this one plus this one. So x plus 4 plus 4 gives us x plus 8. And then these two terms, x plus 4 plus x plus 8, the x's added together gives us 2x, and the 4 and the 8 then gives us 12. Seb cycles from his home to his piano teacher's house on Saturday morning. He stays there for 30 minutes and then returns directly home. At what time did Seb leave his home? So it's between 9 and 9:10, and it's halfway. So of course then that's just going to be 9:05. How long did Seb take to get to his teacher's house? So he left at 9:05 and then he reached the house here at 9:20. So it's 9:20, take away 9:05, and that then is 15 minutes. Seb arrived home at 10:03. Complete the distance time graph. So 10:03, I think we can see then it's going to be here. And so if we join it up like this, that then is the end of the distance time graph. So over the page, what distance did Seb travel in total? So he travelled 8 kilometres to get from here to here, and then he travelled 8 kilometres to get from here to here to get home again. So he obviously then travelled 16 kilometres. Did Seb travel home at a faster or slower speed? So he travelled the same distance, and so how long did he take? It took him 15 minutes here, and here it took him less than that. It only took him 13 minutes to get home. So that was a faster speed. So the answer is faster, because it took 13. Oh, my pencil's just broken here. 13 minutes to get home and 15 minutes to get there. Polygon A, B, C, D, E, F may be divided into triangles. One triangle is shown. Use triangles to work out the sum of the interior angles of the polygon A, B, C, D, E, F. You must show your working. So you can draw them really from anywhere, but if we go from there, that will make us a triangle. And if I go from B again there, and so with 4 triangles, so these angles here add up to 180 degrees. These angles here add up to 180 degrees. These angles here add up to 180 degrees. And these angles here add up to 180 degrees. If you add them all up, these 4 here separately are going to give me the angle B of the polygon that I want. So effectively it's going to be 1, 2, 3, 4 times 180 is what we want. So 4 times 180 degrees, and that then would give us 720 degrees. Question 4. There are 2 boxes of counters. Each counter has a number on it as shown. Mike takes 1 counter at random from box 1 and then 1 counter at random from box 2. Complete the table to show all the possible outcomes of counters taken. So this is box 1 here, which is obviously 2, 4 and 5, and if he gets a 5 and then a 1 from the second box, that would then be a 5, 1 like that. This then would be a 4 and a 2 and then a 5 and a 2. Up here it's a 2 and then a 3, and then a 2 and a 4. Here it's a 4 and a 3 and a 4 and a 4. Here it's a 5 and a 3 and a 5 and a 4. What is the probability that Mike takes a counter with the same number on it from each box? So we have 12 in all here, and the same number from each box. There's one there, it's a 2, 2, and there's a 4, 4, so it's going to be 2 out of 12, which is a sixth. 2 out of 12, and that equals a sixth. The numbers on the counters taken are multiplied. What is the probability of getting an even number? So let's go through them. 2 times 1 is 2, that's even. 4 times 1 is 4, that's even. 5 times 1 is 5, that's odd. 2 times 2 is 4. 8, sorry, we just write even here. Even, even, even. 6 is even. 12 is even. 15 is odd. 8 is even. 16 is even and even. So we have 2 odds, which means then we have 10 evens. So that means it's going to be 10 out of 12, which equals 5 sixths. On another day, Laura takes one counter from each box and multiplies the numbers together. She replaces the counters, does the same thing again for a total of 30 times. How many times would you expect her to get an odd number answer? Well, we're going to be using an odd number. The chances of her getting an odd number is a sixth. And so a sixth times 30, because she does it for 30 times, gives us 5. Estimate the value of 593 over 4.1 times 9.7. The rule for this is we take everything to one significant figure. So this here then is going to be approximately equal to 593 is going to go to 600. 4.1 is 4, and then that's times by 10. So it's going to be 600 over 40, and the answer to that then would be 15. The prize money in a golf tournament is divided between the 3 golfers who finished first, second and third in the ratio 7-4-3. What fraction of the prize money does each of the first 3 golfers receive? Write each fraction in its simplest form. So we need to do 7 plus 4 plus 3 would then be 14. So 7/14 is one of them. 4/14 and 3/14. 7/14 is first place, obviously, so that gets a half because that cancels down to a half. Then that would be 2/7, and then 3/14 doesn't cancel down, so we just leave that one like that. Okay, question 7. Describe fully the single transformation which would move shape P to shape Q. I hope you can see that this is going to be a rotation going around from here. Because this is 3 across and 1 down, and this is 3 across and 1 up, I think the centre of rotation is going to be around there. You can of course use your tracing paper if it's rotation to do a check. Hopefully you can see through that. And if I draw my shape like this, and then I put my pencil here and rotate it 180 degrees, it should land on the other one, if I can be accurate enough here. Rotate it around, and then sure enough it lands straight on the other one, and I know I've rotated 180 degrees. So we would write then a rotation of 180 degrees. Quite often with rotation you need to say clockwise or anti-clockwise, but if it's 180 it doesn't matter. Translate shape P 2 units to the right and 5 units down. So shape P, I'm going to take the bottom corner here, and we're just going to count 1, 2, and then 1, 2, 3, 4, 5. So that point's going to go to there. If we do the same for these ones, across 2 and down 5, of course it'll take us to there, then there, and then there. And with our ruler then, we would fill those in. Label the image T is what it says. So that's image T. Describe fully the transformation which would move shape T back to shape P. Well, if we want to go from T to P, instead of going to the right 5 and down 5, right 2 and down 5, we would then go to the left 2 and then up 5. So 2 left and 5 up. Question 8. Simplify the following. 4y cubed times 3y to the power of 4. First of all, the 4 times the 3 is going to give us a 12. Y cubed times y to the power of 4 then gives y to the power of 7. And part B, m to the power of 4 all to the power of 5 is m to the power of 20. Question 9. Solving an inequality 6y plus 5 is greater than or equal to 2. I would be taking away 5 from both sides. That gives me 6y is greater than or equal to minus 3. And that means y is greater than or equal to minus a half whenever we divide by that. So we just write that down there. Y greater than or equal to minus a half. Write down the smallest integer value of y which satisfies the inequality. So what's the smallest whole number that works greater than minus a half is actually then going to be the next number up from that. The next whole number up from that is 0. Write 25 as a binary number. So let's think about how our binary numbers work. We would have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and that should get us there. That's of course the number 1, and that's a 2, and that's a 4, and that's an 8 and a 16. So how do we make 25 out of that? We of course start with the biggest one, so we take a 16. Will an 8 fit in? An 8 will fit in, so we would have a 1 there. 16 and 8 give me 24, so I only need one more. So I don't want a 4, I don't want a 2, but I do want a 1. So it's 1, 1, 0, 0, 1. Write the binary number, this here, then in decimal form. So we have 1, 2, 3, 4, 5, 6, 7. So again, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 1, 2, 3, 4, 5, 6, 7, that should do us. And we have, that's 1, that's 2, that's 4, that's 8, that's 16, that's 32, and that's 64. And just to be sure, we'll go 1, 0, 0, 1, 0, 1, 1. So it's going to be 64. And there's a 32, and there's an 8, and there's a 1. 64 and 32 gives me 96, plus 8 is 104, plus 1 then is 105. Make m the subject of the formula. So I would want to subtract s from both sides. So that's h, take away s, equals mr. I want to get the m on its own. It's currently multiplied by the r, so we would do opposite to that. I would divide, and so it would be h take away s all over r equals m. For our final answer, we want it written then just the other way around. So h take away s all over r. 2 fair dice are rolled. Make a list of all the ways it is possible to get a total score of 7 on the 2 dice. So you get a 1 and a 6. You could get a 2 and a 5. You could get a 3 and a 4. You could get a 4 and a 3, you do need to include these both ways round. You can get a 5 and a 2, and you can get a 6 and a 1. And those then are all your possible options. Question 13. We have this line here, so the question will be on the page. By drawing a suitable line on the grid opposite, solve the simultaneous equations y equals 2x minus 2 and y equals minus 3x plus 2. So this here is the line. It's going to be, right, what's my gradient? I'm actually, every time I go across 1, I go up 3, but remember that it's going the other way, so it's that's y equals minus 3x. The y-intercept is 2, so that's the line y equals minus 3x plus 2. So I need to draw on the line y equals 2x minus 2. So y equals 2x minus 2, let's just write it here. The minus 2 is my y-intercept, so I know it crosses here. And then my gradient is 2, so that would be across 1, up 2, across 1, up 2, and then across 1, up 2, and we can't see that, but that's okay. And then we join these up. If we're solving them simultaneously, we're looking for where the two lines cross each other, and that's going to be there. So that is 0.8 and then minus 0.4. So x is 0.8 and y is minus 0.4. Question 14. Find the value of minus 2 to the power of minus 2. The minus means here 1 over, so this here is the same as 1 over minus 2 squared. Minus 2 squared means minus 2 times minus 2. That of course gives us a positive number, so the answer then would be a quarter. Make x the subject of the following formula. There's a couple of wee steps here, and people do it different ways, but I'm going to times both sides by the square root of x. That gives me root x y, because if times by that equals b. I then want to get the root x on its own, so I'm going to divide by y. So root x equals b over y. And now I want to square both sides. So you can either stick a bracket around it and put squared, or you can just square them both. So it would be b squared over y squared. So I put that answer in there, b squared over y squared. On the graph, draw the reflection of the shape W in the line y equals minus x. Y equals minus x is one of the lines you should know. If you've forgotten it, you can use y equals mx plus c. The gradient is minus 1, and the y-intercept is 0 because there's no c term, so it kind of goes there, and the gradient of minus 1 is across 1 down 1. So it's that diagonal line, the 45 line, going this way. We have to do a reflection then in the line y equals minus x. Now this is a complicated one because it's a diagonal working line, and generally what I tell people is you reflect it using your perpendicular working lines. So that's 2 diagonal squares across from there to there. Do you see that? 1, 2. So I would go 1, 2 right this side. This is 3 squares across. 1, 2, 3. So I do the same here. 1, 2, 3. It's a tough one actually, I think. This is 1 and a half. 1, 1 and a half. So we go 1 and a half. This here, remember, keep it diagonal. 1, 2 and a half. A half. 1, 2. See how it's looking. That's 1, 2, 3, and this then would be 1, 2, 3. And those are all something I think tough about drawing these shapes, especially whenever the reflection lines are diagonal, but this is what we're looking for. And we end up in with that. Question 17 is our final one. There are 3 main routes from Balik to Enniskillen by car. There are 5 main routes from Enniskillen to Fintona by car. How many different ways can James travel from Balik to Enniskillen to Fintona by car using only main routes? Well, if there's 3 main routes, I mean, you can draw a wee diagram out if you want. It seems a bit weird, but that would be from Balik to Enniskillen. And there's 3 ways you can go, 1, 2 and 3. And then Enniskillen to Fintona, you can go either of 1, 2, 3, 4, 5. So we can go this way and any of these 5, so that's 5. This way and any of these 5, that's 10. This way and any of these 5, so that would be 15. People can just work that out in their head, and of course writing an answer of 15 is totally fine in that scenario. On a particular day, 2 of the main routes from Enniskillen to Fintona were closed. By what percentage has the number of ways for James to travel from Balik to Enniskillen to Fintona by car using only main routes been reduced? So 2 of those are now closed. Isn't that right? From Enniskillen to Fintona are closed. So we can go this way and any of these 3. This way and any of these 3. This way and any of these 3. And so by what percentage has the number of ways been reduced? So it's been reduced by, it's from 9 down to 9 now, so it's been 6. So that is 6 out of the 15 ways it has been reduced. That cancels down to 2/5, and 2/5 then hopefully you know is 40%. 2/5 is the same as 4/10, and so your answer then is 40%.